Yeah, let's get started. My talk is entitled Developing an Experimentation Platform with FastAPI. I must say that this is quite a broad topic, and um, yeah, I hope you'll bear with me, and the focus will be a bit more on the Python and maybe engineering development side, and not so much on the experimentation part. But I'll try to introduce that as well so that you get the context. Yeah, just before jumping into that, quickly introduce myself. So I'm Larissa, as Adam mentioned, and I'm a data engineer here at Wolt. I've been working since June last year, so 1 year now, in the core machine learning and data engineering team, which is mainly responsible for building and maintaining our data infrastructure and services. And so there's a lot of data engineering work on that. But actually, my main focus has been on building this experimentation platform that I'll talk a bit about right now. And well, my background is on software engineering, and I've always had a thing for data. So the shift to data engineering seemed quite natural through my career. And when I'm not working or programming, my main hobbies are lifting weights and also used to be traveling. Let's see when that's actually possible again. And yeah, feel free to reach out. I've put there my email and also my GitHub handle. So if you have any questions or anything, just feel free to contact me. But yeah, I'll briefly introduce what an experimentation platform is and give a brief technical overview of our solution. And then as following the title of the presentation, mention like why we chose FastAPI and discuss a bit about the challenges and learnings when developing this tool, and then end up with a real life example of an A/B test that we've run using this platform. So yeah, just a disclaimer, I don't consider myself an expert on this, on FastAPI or on the some of the technologies I'm gonna explain, but just yeah, I think it's interesting to show also some of the learnings that we've had when using these technologies, but I'm not an expert on those, just a disclaimer. So yeah, an experimentation platform, as the name suggests, is basically a platform where we can run experiments with the goal to make product development more data-driven. And I think it's sort of kind of common knowledge that most product companies, after a certain stage, maybe not in the very beginning because it adds a bit to the whole feature development process, but after a certain stage, they must be doing some sort of A/B testing and preferably integrated to their product development cycle. So just diverging here a little bit for if there is people in the audience who are not familiar with A/B testing, just explaining what it is in very brief terms. So A/B testing is basically comparing two versions, or in this context, we call them variants. And two versions, A and B, as you can see in this little picture, of the same sort of feature, or in this case, like same website, but slightly different design. And then you measure your key business metrics, as in this example, conversion. So with these two different versions, which one drives more conversions to your website? And then, of course, you have to split your audience 50-50 in this case. So half of your users saw A, half of users saw version B. And then you are able to compute your conversion or your business metrics from that. So the whole goal is to validate any changes that you make to a product by testing it with only half or a subset of the users, and then measuring your business metrics between the different groups and to see which one performs better. So yeah, with that in mind, we've developed our own in-house solution that we call it experimentation platform, because it doesn't it's not only focused on A/B tests, even though that's kind of our main use case, but it also supports or is supporting on the way to supporting different types of experiments. For example, feature flags and gradual rollouts, I think, are the main ones always associated with A/B testing frameworks and platforms. But yeah, this solution is, of course, tailored to our own domain here at Wolt, and allows us, building it ourselves allows us to have, of course, much better control on how this is integrated with all our different services that are involved in product development here at Wolt. So if, yeah, just in case you wonder why choose like an in-house solution instead of kind of going with something ready-made. But yeah, this was a very brief introduction to the problem and the context. And then going a bit more technical, this can be kind of considered as a high-level technical overview of what our solution consists of what this platform consists of. So we have three main components. Of course, one of the components is related to creating and managing these experiments or these A/B tests. And we need to be able to assign, once we have an experiment, to assign users to the different versions they are supposed to see. And then we do that through this assignments API, which integrates with our different internal services. And then all the data that is generated based on that. So user A is assigned, or user X is assigned to variant A. All of this data, we need, of course, to store it to be able to calculate metrics. And then we do that using Kafka. And the central element there in the picture is our data warehouse. So from this assignments API, all the exposure data goes to our warehouse through Kafka. And yeah, just to give a bit more context in this picture, we use Postgres as our operational database, although this is not super relevant for the context of this presentation. And Redis as a distributed cache, as performance is something very critical in this case, as you're gonna see a bit later on in this talk. And then, of course, from all this data that we gather, we compute our metrics that are then displayed in the form of dashboards, so that it allows us to make better informed product decisions based on the results of the experiments. But yeah, so why did we decide to go with FastAPI to develop this solution? So yeah, one of the reasons was a lot of people were talking about that. We wanted to see what this was about. Why is it so great? And well, it had good promises of being fast, and this is something that it was very relevant for us in this context, because part of as you saw here, the assignments part integrates with our internal services, and performance was really a constraint for us, especially on this part. But in addition to that, FastAPI also has some great features, not only like great documentation, but also automatically validating data and generating error messages so that you don't have to do it yourself, as well as documentation generated automatically from source code, which is something that for us is quite awesome because, of course, in general, developers want to spend as little time as possible dealing with documentation. And in this case, it's a tool that is used by many different services at Wolt. So we need the documentation to be good, up to date, um, and effective. So this helps a lot. Doesn't solve all the problems, but it helps a lot having this automatically generated from source code. All right, but what about the main challenges that we've faced during this whole process? We've sort of released, let's say, version 1 of this platform, but of course, this is something that it's in constant development still, and um, there has been some challenges that I'm gonna introduce here, but we're pretty sure there are plenty of others to come, and this doesn't mean that we've solved all the problems and everything. But yeah, let's get down to it. So one of the things is that async in Python is like not super mature. It's getting there, but it's we started this almost 1 year ago, and it's become better since then. But yeah, it wasn't maybe as mature as we would want. And this mainly reflects on some of the main libraries and drivers, like database drivers, not supporting async by default. For instance, like SQL Alchemy latest version was released, I think February or sometime early this year. So when we started this, it wasn't even supported. And then also FastAPI doesn't really enforce that you use async, but then of course, if you don't, then all the nice performance benefits that the framework could have or claims to have, then it's not, you don't really gain that much from it. And we started our service not maybe not taking that too much into account. And then as we progressed, then we realized how important it was. And then kind of as a combination of these things, we spent some time kind of figuring out certain bottlenecks in the code. And also, as I said, performance was a constraint in this case. So of course, we want to keep track of our latency and anticipate possible increases before deploying something to production. So what did we do then about these challenges? Well, the first one is, as already talked about it a bit before, there is not that much to do apart, just kind of keeping up to date with the tools and libraries as they start supporting async and as they get their new updates. Although we haven't yet tried SQL Alchemy latest version that does support async, that would be maybe my advice there, that always look for the libraries that do already support, or keep an eye when they're coming next in the tools that you use. And then, as I said, initially, we weren't maybe too worried about that. We had some kind of legacy code that we ported over here, and then that was done in Flask. And then, of course, as you know, there was no async or anything like that. So we were reusing some of the things that didn't have async support, and we didn't have the latency that we expected, let's say. So one of the first things that we did after like one of the first initial releases was to replace this default or this main Redis library with AIO Redis, which then supports async. And I hope this chart is clear enough to show that there was a big drop in the latency, and especially the P95, which is the highest one. they're really stabilized as compared to before. So this was, yeah, one of our first wins. And then we also, kind of in this same context, we also had a previous solution using Celery and Kinesis Firehose. And then we moved that to Kafka, like in the context of logging the user assignments. And I will show in a following slide the impact that this had on our latency as well. So yeah, and then for the third challenge, well, that's basically something that maybe you might consider looking at for your project. So what we did was basically we integrated some code inspection tools to our workflow and into our project. I've listed these 3 ones that we've tried. I'm not an expert on any of these, and this is just something that we used and might be worth checking out if you're interested in kind of monitoring your latency and adding these code inspection tools to your workflow. But yeah, this is a bit out of the scope of this presentation. So just a little bit back to what I was mentioning before. So these were 3 kind of important points in our kind of development. I think here, yeah, this goes around 3 months. So from January and until March, 3 kind of main things that we did after taking all of these points into consideration. So the code inspection tools helped us identify certain bottlenecks, like we introduced authentication in the API. And then after, yeah, this number 1 highlight, and then we saw that latency went up, and then, okay, let's cache the authentication token so that we improve a little bit on that. And it's maybe not so noticeable as the third point or the third figure there, but it improved a bit the latency and stabilized it a little bit. And then the last and biggest and best one was when we moved, as I mentioned before, from Kinesis Firehose to Kafka. And we also added some additional caching. It wasn't only that, but this was kind of the main chunk of this work. And you can see, I think, quite clearly the impact that it had on our latency. So this is more or less probably the main change that we've done there. So yeah, just a brief summary then of the stuff that I've just mentioned about our challenges and learnings. So what we've learned basically is that, of course, always try to use async compatible libraries and database drivers if you really want to benefit from FastAPI and from the performance side of FastAPI. And especially if latency is a concern, make code inspection tools as part of your workflow. And then also finally, if applicable, this is, yeah, I think there are cases and cases, but you might want to consider using Kafka if you have some sort of real-time or messaging service requirements. And to wrap up, as I said, I was going to show an example of an A/B test that we've run in the context of Wolt. So I don't know if you guys are, or how much you guys are familiar with this screen. So this screen shows whenever you're not in the delivery area. So this one on the left was our old experience. And sometime in the second semester of last year, we've run this test by replacing this old out of delivery area screen with this other version. And we actually saw 9% of uplift in conversion. No significant change in retention, but it was a quite positive experiment overall with good results. And yeah, this has been made the default screen for the outside of delivery area, which you probably are familiar with. So this happened sometime last year. But yeah, I think that's all for me. Thank you. Let's see about the questions.
Thank you, Larissa. That was fantastic. I gotta say, I have used your tool and it was phenomenal. I cannot believe this was an in-house tool. All the infra tools I've used before in my life, I've always that looking kind of show that you kind of like haphazardly made. That looked epic. Right. So a couple of questions. Let's start. Did you profile in production?
Yes, we did, but we had to be like extra kind of careful there. We would only turn the profiler on for a few minutes and then of course you have to choose the times wisely when there is enough traffic, but probably not in the peak of your traffic, so that your service doesn't become too slow. But we did not extensively, but whenever there was, we felt we would benefit from it, then we did.
Great. Next question. Did you consider any async libraries other than SQL Alchemy? I don't know some of them, e.g. Geno, async PG, and so on and so forth?
Yeah, good question. We actually, I looked into it, but we didn't actually consider changing, mainly because our Postgres, as I said, we use as our operational database in this service. But for the Postgres use case specifically, we didn't have these latency requirements. So as I mentioned, we are using Redis for distributed caching and for the endpoints that we need very good performance. Then we are relying on that currently. So that's why we haven't put the effort into either like trying the new SQL Alchemy version or moving to some other library. But we looked into it, just didn't act on it, basically.
Yeah, absolutely. I mean, it doesn't make sense to pre-optimize if there's no need. And if the latency comes from Redis, that's what you do. And I have to say, like the new SQL Alchemy announcements, like the 1.4 version that you mentioned, finally supporting proper async, made me so happy. Because before that, there was very little reason to go async. Like, why? I mean, most of my work is IO bound anyway. So what am I going to gain from that? So yeah, 100%. Next up, we have, how was the learning curve getting into async IO?
Yeah, that's a good question. It wasn't very steep, but there was maybe some difficulties, I would say. Of course, it depends a lot on your past experience. So if you haven't ever done it or haven't ever programmed with async, then there will be there is a curve, but it's, at least I didn't find it very steep. But there is, and right now there is a lot of content out there that helps if you want to get started. So
absolutely. And no, I want to, oh, there's one more. I never get to ask my questions. How will you and the team, if any, consider applying FastAPI with microservice architecture? Are there challenges that you may think of, or is it similar to Flask?
Yeah, good question. I think others might answer that better than me, because I think Jero is gonna talk maybe a little bit about that on his talk. So we could leave that for that moment. But right now, at least, I cannot think of like challenges as compared to Flask, or I mean different challenges as compared to Flask.
Right, we have one more minute and one more question, and anything else will have to be done post meetup. So, hey, Larissa, good presentation. Complimentary question from the data science side. Are there certain reasons why Wolt is using A/B testing instead of other alternatives? For example, it is known that A/B testing is a great option when the goal is understanding rather than optimization and fast learning from the data. Just wondering what's Wolt's use cases and justifications for A/B testing. Yeah, that's it.
Yeah, that's a valid point, and I think at least the way we see, I'm not a data scientist, but at least my understanding from, of course, talking with data scientists and kind of knowing the use case is that we treat it actually as a learning kind of experience, not necessarily we're gonna force the result to kind of let's say make us choose a feature, or we do treat it as a learning experience here at Wolt. At least that's my understanding of the mindset from some of the A/B test experiments that we've been running. So I don't know if that fully answers your question. Maybe we can discuss that further.
Absolutely, absolutely. I just want to tack on and say that as a newcomer myself, I actually found it to solve a dual issue. On the one hand, you have a hunch, you have a question, and instead of necessarily doing the data science analysis, you just say, hey, what if we change that? Or I assume that this is causing whatever, a drop in retention, whatever. And then you get to both do the analysis and potentially solve the issue at the same time.
Yeah,
I'd say that it's not one or the other. I think they both complement each other very well. So, all right, that's all the time we have. Thank you so much, Larissa. That was fantastic.